Hello everyone, welcome to Source's classes. This is Tushar Shaw, and in this video we'll be continuing to solve the GATE 2021 CY papers that we were solving since the last 12 videos. Okay, so obviously in the last video we did up till question number 32. Okay, so in this video we'll be starting from question number 33. Okay, obviously the organic questions are going on because in this question paper, in the pattern you can see that the maximum organic and inorganic questions are given in the MCQ and the MSQ part, and all of the physical questions are given in the NAT questions. Okay, so we'll be looking into that. So obviously organic questions are going on. So the question number 33 is also one of them. So let us start. So this question says that a reaction is given. We have two steps of the reaction, P and Q. So we have to write down the product P and Q. So the reaction that is given is um, we have O. So this one is okay. Then sec bully butyl lithium THF obviously plus ZnCl2 is given. Okay, this would be forming the product P, and then we give the bromide derivative of pyridine, that is this one, and then PdPPH4 whole PPH3 whole 4 THF. This would be giving the compound Q. Okay, so let us write down the mechanism step by step. We will be understanding it quite better. So this group, firstly let us discuss about the functional group that is given. So this group is known as the MOM group. Okay, MOM. The full form you can look it up on Google. So that is the main thing. So this group is obviously um, strong orthodirecting. Okay, strong orthodirecting. Okay, strong ortho like it is a strong ortho-directing group, so the reaction would be occurring in this way. So we give the lithium atom will be if we when we give sec bully, so sec butyl lithium, when we give it, so the compound would be forming this kind of chelate with the lithium. So O, then this would be forming an calculate with the lithium ion. So this the sec Bu minus ion would be taking up this hydrogen from the system. Okay, so here a minus charge would be formed. Okay, so this minus charge would be incorporated with the lithium ion obviously. Okay, so we have a lithium over here, we have the MOM group over here as it is, and then we have this the other hexocyclic ring. Okay, so obviously now this what would happen is this ZnCl2 in the next step would be attacking over here, forming a zinc organometallic compound. Okay, so ZnCl2 would be attacking over here, leaving with NiCl as the one of the byproducts. So this would be formed, and then O, and here we'll be having ZnCl2. Okay, so yeah, so that not ZnCl2, ZnCl will be there. One Cl will be removed from the system via with the in the form of LiCl. Okay, so this is the product P which is formed. Okay, now in the options you can see that only one option, that is option B has this product. So we already know that B would be the correct answer. So before let now before judging the answer so quickly, let us solve for Q and whether the Q is also forming the same or not. Okay, so what would happen is this, if you give the bromine derivative of pyridine, okay, and this is obviously given in the presence of PDOSC or PPH3 whole 4. Okay, So OSC whole 4. What would happen is this ZNCl would attach its this Zn would be like bonding with the Br over here to remove to get removed as ZnCl Br, and this pyridine would be attached to this system. Okay, in the ortho position only. So we'll be having okay. So this is the product Q which will be formed. Okay. Now, in the options you can see, I have already told you that option B here has both the products P and Q as we have obtained in this question. So, option B would be the correct option. Okay. Now, one thing I would like to inform you about this reaction, that this reaction is known as Negishi coupling. Okay. The reaction is known as Negishi coupling. Okay. So obviously this would be the major product and the minor product would be there one also. So but that is not a concern over here. Okay. So yeah. So you can look this reaction up on Google. So you will be finding quite a lot of number of examples here regarding this. Okay. Moving on to the next question that we have, that is question number 34. Okay. Now this question is an easy one because it is obviously a sum. So it says that in an electrochemical cell, Ag plus ions are taken in Ag plus ions in form of AgNO3 are reduced to Ag plus ions, sorry, Ag plus in AgNO3 are reduced to Ag. Okay, and metal in the cathode and in the cathode. So this reaction is occurring in the cathode, and Cu is oxidized to Cu2 plus at the anode. Okay. Now, the current given is the current that is passed to the system is 0.7 ampere, and obviously for it, the time that is given is 10 minutes. Now we'll be working with the SI units of each and every that value that is given. So let us convert this minute into seconds. Okay, so 10 into 60 seconds will be giving you 600 seconds. Okay, and the question asks that the mass in grams of silver deposited and the copper dissolved respectively are. Okay, so this is a sum involving the Faraday's constant, and therefore we the value of Faraday is given to be 96485 coulomb mole inverse, and atomic weights are given. For Ag the atomic weight is 107.9, and for Cu the weight is 63.55. Okay, so let us solve this question. So uh, the formula for the main formula that we require for solving this question is W is equal to, that is the weight of the product dissolved, is equal to E into I into T divided by F. Okay, where E is the equivalent mass of the compound, I is the current passed, and T is the time taken. Basically, the formula is EC by F, where C is the charge passed. Now charge is equal to a current into time, so that is the that is hence where we will derive it. Okay, so let us find out. So for Ag plus, firstly for Ag plus we will be finding out W is equal to the equivalent weight. So 10 the equivalent weight, let us write the formula. So equivalent weight is equal to molecular weight divided by basicity. So here basicity is 1, as it is 1 plus, and for Cu2 plus Cu the basicity will be 2 there because the charge is 2 plus. Okay, so for Ag, so for silver we will be having 107.9 divided by 1, which will be giving 109.7 only, 107.9. Okay, into 0.7 into 60 uh, into 600, sorry, as we have calculated. Okay, divide by the value that is given 96485. Okay, let us calculate this value. So we have 107.9 into 0.7 into 600 divide by 96485, which gives this gives 0.4697 grams. Okay. Now for the copper system, let us calculate that. So for Cu2 plus, we'll be having W is equal to, here the basicity will be the original mass of Cu, which was given to be 63.55. Equivalent weight is equal to, it is equal to 63.55 divided by basicity 2. Okay, so here we'll be having 63.55 into 0.7 into 600 divide by 2 for this case into 96485. So let us calculate this also. um, 63.55 into 0.7 into 600 divide by 2 divide by 96485. This comes out to be 0.1383 grams. Okay. So in the, let us now, we got the answer for both the cases. Let us now compare the in the options. Okay. So in the options you can see that option 4 has the first value to be 0.469, which matches with here, and the next value to be 0.138, which also matches here. Okay. So option 4 would be the correct answer. I'm sorry, not option 4. Option D would be the correct answer. Not option D actually. Option A. Okay, option A. I had the different set of paper. So option A would be having this for point for 0.469 and 0.138. So option A would be the correct answer. Okay. Moving on to the last question of this video. That is question number 35. Why I said last? Because this is an extremely big question, so we'll be requiring quite a lot of number of times for solving it, and therefore the time for this video would be finished. Okay. So the compounds which can be prepared by nucleophilic substitution are, okay. So let us write down the the compounds that are given. So the compound that can be prepared by nucleophilic substitution. So the first compound that is given is N3, and so here the nucleophile should have been N3 minus. Now N3 minus cannot directly attack into the system, because here if the this is structure 1 obviously. So N3 minus cannot attack in the system directly here. Why? Because this would be considered a case of nucleophilic aromatic substitution. Okay, nucleophilic aromatic substitution. Now for this substitution, for this nucleophilic aromatic substitution to occur, there must be a strong electron withdrawing group either by minus I or minus R present in the system, so as to the negative charge that would be formed during the transition intermediate would be stabilized in the system by going into delocalization. Okay. So this effect is not observed in the case number 1. So therefore this group won't be going into this compound won't be forming by nucleophilic substitution. Okay. So the next compound is OAC, and this one is OAC. Okay. So in the this one obviously doesn't exist in the planar form. So let us draw this in the chair form. Okay. At one time it is OAC above plane. I'm sorry. This one is so yeah. So this is below plane, obviously OAC. Obviously it will be equatorial, so let us draw it in that way. Okay. So this will be OAC above plane, OAC, and here it will be below plane, OAC. Okay, so this can obviously be formed from nucleophilic substitution. Obviously, if there's a group OTS in the initially present, then we can give the OAC group. This is a whole reaction mechanism. I have already explained it to you while I was teaching you the stereochemistry section of organic chemistry. Okay, the cyclohexane part. So in that part, I have already explained it to you how this reaction would be taking place if there's an via nucleophilic substitution. If there is an OTS group present. Okay, so this group can be this two. So compound number two can be formed by nucleophilic substitution. Okay, so compound two will be formed. The third compound is mm, Br. So this is compound 3. So this I would either go by SN2 or by SN1. Okay, so but in this case you can see that obviously the SN2 is not possible over here because this is an extremely bulky group and therefore the nucleophile approaching is not possible over here. Okay, and obviously SN1 is also kind of not possible because though the carbocation that is formed is extremely stable, that is the because of the 3-degree carbocation, but this also the in like if the carbocation is formed, this would also disobey the Brett's rule, which is not allowed. Okay, because of the bridgehead carbon that is present, so that would also be not allowed. Okay, so the 3 won't be under formed under nucleophilic substitution. Okay, so yeah, so let us now form write question number 4. The option 4 that is given is SH NO2 NO2. Okay, this compound can undergo, this is obviously question option number structure number 4. This compound can obviously undergo nucleophilic aromatic substitution, that is this one. Okay, why? Because both in the ortho and para positions there are two extremely high minus I and minus R exerting groups. Okay, the strong minus R exerting groups are present there, so the transition state when formed when H was being replaced by SH, then that intermediate can be would have been highly stabilized by the minus I and the minus R effects of the two NO2 groups present at the ortho and the para positions, and therefore making this nucleophilic aromatic substitution possible. Okay, so this one would be formed. Moving on to the next structure, that is, so here all the carbons that we have in our system are sp2 hybridized. Okay, this is obviously structure number 5. So all of them are sp2 hybridized. So none of the carbons would be undergoing any type of direct nucleophilic substitution. Okay, so this won't be having any reaction as such. And the last one would be kind of easy. So OMe. This is an sp2 hybridized carbon, so a nucleophile, a good nucleophile that is OH minus can enter into the system, removing this OMe, forming the OH, and therefore making this nucleophilic substitution possible. This is structure number 6, and it undergoes nucleophilic substitution. Okay, so we got that 2, 4, and 6 would be showing nucleophilic substitution in the following structures. Okay, so in the options you can see that option C, okay, option C has 2, 4 and 6, and therefore option C would be the correct answer over here. Okay, so that was all about this video. I guess we have solved many questions. This big question was quite a huge thing to explain, but that is okay. We crossed a good barrier. So in the next video onwards, we'll be starting from question number 36 in this case. Okay. So I guess two videos will be required, and then we'll be completing the MCQ part of this question, and then we'll be moving on to the MSQ part of the 2 marks question. Okay. So thank you guys for this video. I'll see you guys in the next one.